Hello everyone, I am Assistant Professor Dipali Wavhal from Department of Chemistry, SICS, Degree College of Arts, Science and Commerce. Today we discuss topic electrochemistry. What is electrochemistry? In electrochemistry, we study production of electricity from spontaneous chemical reaction. Otherwise, we also define as electrochemistry is use of electrical energy. It is use of electrical energy to bring about non-spontaneous chemical reaction. For spontaneous chemical reaction, it is production, and for non-spontaneous chemical reaction, it is a use of electrical energy. In two different types we explain the electrochemistry. Electrochemical cell or galvanic cell or voltaic cell. Electrochemical cell and electrolytic cell. Electrochemical cell produced electricity, electrolytic cell using electricity. Here example for electrochemical cell, Daniell cell, and electrolytic cell, recharging batteries and electrolysis of water, that are example of electrolytic cell. See this is the diagram of galvanic cell, in which zinc rod deep in zinc solution, copper rod deep in copper solution. Here we use salt bridge. Here we see anode, cathode, all these terms we discuss. See this diagram of galvanic cell. Here anode oxidation, here cathode reduction. What is mean by oxidation reduction? Oxidation is a gain of, see here, oxidation is a loss of electron. See, zinc is converted into zinc 2 plus 2 electron. These 2 plus, that is 2 electrons are loose from this zinc metal and get converted this zinc metal into zinc metal ion. Here copper 2 plus 2 electron get converted into copper. So this metal ion is converted into metal. This reduction half reaction. We have get the complete cell reaction. See here, zinc get converted into zinc 2 plus, Cu2 plus converted into Cu, and this cell reaction complete. This is a complete cell reaction. Here in a galvanic cell, half cell in which oxidation takes place at anode. So here electron addition or electron loss, two types of mechanism: loss of electron, oxidation; gain of electron, reduction. Reduction takes place at cathode, oxidation takes place at anode, and it has a positive potential. So this both the oxidation and reduction reaction takes place and having a positive potential with respect to solution. So here salt bridge. What is mean by salt bridge? We see in previous slide the diagram of Daniell cell. In that we discuss the we use the salt bridge. This salt bridge is a U-shaped tube which is made up of semi-solid paste of some inert electrolytes like KCl, KNO3, NH4Cl in agar or gelatin. Electrode potential. What is mean by electron potential? The tendency of metal to lose or gain electron when it is in contact with its own solution is called electrode potential. So we discuss in that example, in that diagram, zinc rod in zinc sulfate solution, copper rod in copper sulfate solution. According to that we find electrode potential. According to that we find their potential, which is the electrode potential. A potential difference develops between electrode and electrolyte, which is called electrode potential. We see zinc is a electrode and zinc sulfate as a electrolyte, and potential difference between that is a electrode potential. Here standard electrode potential. What is mean by standard electrode potential? All the species involved in half cell is unity. All the species involved in half cell is unity, then the electrode potential is known as standard electrode potential. According to IUPAC convention, standard reduction potential are known now called standard electrode potential. So, standard reduction potential is a standard electrode potential. What is meant by cell potential? First we discuss electrode potential. This is the difference between electrode and electrolyte. Then we discuss standard electrode potential. Standard electrode potential is the standard reduction potential according to IUPAC convention. Here we discuss the cell potential. Cell potential is the potential difference between two electrodes of galvanic cell is called the cell potential, is measured in a volts. It is the difference between two electrodes of a galvanic cell. We also called as a cell. E cell is also called as the electromotive force, EMF. Cell potential having a formula E of cell is equal to E of right minus E of left, or E of cell is equal to E of cathode minus E of anode. These two formulas are same. Here right hand side reduction on cathode, left hand side oxidation on anode. So, both these formula representing both these formulas meanings are same. In next, representing a cell. How we represent a cell? Oxidation and reduction. In half cell oxidation takes place, half cell reduction takes place. These two cell we represent as like this. This is a cell representation. So, here zinc metal ion, zinc 2 plus metal ion, here copper 2 plus copper metal ion, and here copper. So, in representation cell, here anode is kept on the left and the cathode on the right. Anode left hand side, cathode right hand side. When we draw the or represent a cell in a paper, we draw anode left hand side and cathode, write a cathode on right hand side. In anode, metal is represented first followed by metal ion. In anode, metal represented first followed by metal ion. See here we discuss that example here. Anode metal ion, copper metal ions metal, here oxidation, here reduction. So, in that way we write the oxidation and reduction half of cell. Put a vertical line between metal and metal ion. In that metal and metal line, put a vertical line and double line. Salt bridge is denoted by putting a double vertical line. A double vertical line between these two half cell indicate the presence of a salt bridge. So, the total representation of a cell denoted by like this. See here, zinc rod dip in zinc solution, copper rod dip in copper sulfate solution. Here we have obtained the EMF value greater than 1.1 volt or less than 1.1 volt. When we obtain less than 1.1 volt, zinc dissolve at anode and copper deposited at cathode. Here zinc dissolve, okay. Here copper deposited on this plate. These are effect of opposing potential. When the electrode potential value is greater than 1.1 volt. In first slide, previous slide, it is less than 1.1 volt. In that current slide, it is a greater than 1.1 volt. This mechanism is reverse. Here zinc is deposited and copper dissolve. Copper dissolve in that solution, zinc deposited on this plate. Effect of opposing potential. Potential oppose hai, so that effect on potential, electrode potential. See this, measurement of electrode potential. We can measure this electrode potential by using a standard hydrogen electrode or normal hydrogen electrode. In that cell we use electrode, one is a reference electrode, another one is a indicator electrode. So here standard hydrogen electrode, with respect to that standard hydrogen electrode we determine the cell potential. See this standard hydrogen electrode, this platinum electrode coated with the platinum black, this platinum electrode coated with the platinum black. Electrode is a deep in acidic solution of a 1 molar concentration at a 1 bar pressure and 298 Kelvin. We all have known this is a standard hydrogen electrode. So here standard hydrogen electrode act as a cathode or it act as a anode. If it act as a cathode, then we represent the cell like this. When cathode, reduction. So reduction, gain of electron, oxidation, loss of electron. When gain of electron, so here plus sign, okay, at a left hand side, here plus of electron at right hand side we write. For reduction we plus 2 electron at a left hand side, and for oxidation plus electron at a right hand side. So the half cell reaction can be represented as like a this platinum with H2 1 atmospheric and vertical line H plus. So here electrochemical series, according to that standard hydrogen electrode, the series which is used or series which is developed, we called it as a electrochemical series. What is meant by this electrochemical series? This electrochemical series in which various electrodes are arranged in the increasing order of their reduction potential, arranged in increasing order of their electrode potential. So here electrode potential, see this hydrogen electrode has a value 0.00, according to that value are increases, and here value are minus value above plus value. This fluorine has a value plus 2.87, and here lithium electrode has a value minus 3.05. The more positive E0, greater the tendency of substance to be reduced. This substance is reduced, and this more negative value, the substance will be oxidized. So the sign of E0 changes when the reaction is reversed. Reaction is reversed. Here we get the reduction plus value, here get the minus, here a oxidation. So these electrochemical series, here oxidizing agent, so increasing strength, here oxidizing agent, and here reducing agent. This electrochemical series is useful for comparing the relative oxidizing and reducing powers. Substance with the higher reduction potential are strong oxidizing agent. Fluorine has the highest electrode potential, thus fluorine has a strongest oxidizing agent, and lithium metal has a more powerful reducing agent in an aqueous solution. So according to that series we identify oxidizing and reducing power of another one power of a electrode. Another one application, see these applications of electrochemical series. With the help of this formula we determine the EMF of the cell. So here zinc and copper cells EMF, according to that electrochemical series, here we see for zinc minus 0.76 and for copper 0.34. Here we use that value and find the EMF of cell. Third applications of electrochemical series, predicting the feasibility of redox reaction. The E0 value is positive, reaction is a spontaneous or feasible. E0 value, according to that value we find out the E0 value is a reaction is a feasible or not feasible. This is the third application and last application of this electrochemical series, predicting the capability of metal to displace hydrogen from dilute acids. The metal having a negative reduction potential can be displace hydrogen from dilute acid. So these predicting the capability of metal to displace hydrogen from dilute acid. So these 4 are applications of electrochemical series we study here. Thank you.